So maybe you were just talking about this, but I think we've only got one point on the agenda today. Andra, do you want to introduce it?
Yeah, sure. I'm now looking into what's missing for insights, and we are discussing quite a lot about where we want to go and looking into what Konflux is doing. And we've noticed that Konflux is actually changing the container file during build. The build task is adding the cache2 environment for each run, which I just wanted to bring up here and hear what everyone thinks about that, if that was a design decision, if that's all right, or if that's just a workaround and we want to change it in the future. Because to me, it feels a bit wrong to change the source file that we are building from, but yeah, I don't really know enough to judge it here. But there was quite a huge discussion around it, and there are people on both sides of the spectrum. We should do it because that's the best way to do it. And then on the other side of the fence, people who really think that we can't really change source code and call it a reproducible build. So yeah, I just wanted to bring it up and hear your all's opinion.
I'll go first. I thought, I think a thing when I'm considering changes to other Konflux build tasks that I watch out for to try to reject or stop is if something is gonna be brought into the build that is not determined fully by something else in the commit. So in that way, it's changing the container file, the Docker file, but it's doing so in a way that's fully specified by other stuff that's already in the commit. If it were making a curl to some other destination that we can't control or check the contents of that during the build, and then using that to modify the source, to me, that would be the mark of an unreproducible build, because it depends on the state of something else at the time that the build happens. I guess to try to empathize with the point of view you're bringing up, that the build is not reproducible in that if you submit it to Konflux and let it build, but then if you try and use Podman or build it locally, you're going to get different, you could potentially get different different outputs, and that I think is true. But if you were to have like a local kind cluster and then installed Konflux and Tekton onto that, and then used the Konflux build task that's specified in the Git repo in the .tekton file, you should be or would be able to reproduce the same build that you would get in a remote Konflux cluster locally. That is a lot of overhead to try to do that.
Yeah, I read this point as well, and I agree. Although, of course, people would love to be able to build it through Podman and verify that it builds the same thing, right? Because it's now you need to trust the Konflux or really install Konflux on your development machine and run the build yourself to really be able to verify that you are running what the source code is saying you are running. But yeah, as I said, I don't have really strong opinions here, but it just sparked a huge discussion, and people on my team feel a bit strong about one way or the other. So I wanted to really hear what's the opinion on the team.
Just looking at Stack, I see Louis, and then Adam, then Andrew.
Yeah, and I think I'm thinking here of the inner feedback loop, right? Like you're trying to hack on a project before making a commit, and you just want to be able to verify that things are working locally. And setting up Konflux locally, that's not going to be an easy task. But the the builder task that Konflux uses is a lot more, and this is a pattern that just keeps going more and more. It does much more than what just regular builder does, right? There's like all this stuff that happens to support Catcher 2. Now there's like stuff for, entitlements and things like that. And none of that is easily available outside of Konflux. And I think that's a gap, and I think that's probably something we should try to look into, where it would be wonderful if you have all the input, all the the Git clone and all that stuff, all the input that's given to the builder task. If you were able to get that and then just run whatever the builder task is doing locally, I think that will be super useful to users to be able to debug things and shorten that inner loop. I don't know if that's exactly what Andred is looking for, but as a developer, as a user of Konflux, that would help me, iterate on things much faster.
And on top of it, it would help the local reproducibility of the build, right? There are hands raised.
Yeah, Adam, you can go for it.
Yep. Good to be back here, first off. But I can absolutely sympathize, Andrej, with the situation you're going through. I feel like I've run into the same kind of situation outside of Konflux with OpenShift and OpenShift CI system, where OpenShift has its own kind of CI registry where those images, the base images, are not easily accessible. And it's kind of a common thing that I've even seen with like customers doing builds on OpenShift since even the 3 days. I think that's actually part of what motivated image streams. The fact that you could kind of effectively alias things, and in OpenShift 3 you could kind of say, oh, my build's you could have like a local Docker file, container file, but in your build process it's just alias to some other image that's kind of like owned by a platform engineering team. I frankly don't like that pattern. I'm more aligned where you want to go, where you want as much defined in that your source code as possible, so that you can interloop to the best way you can. To Louis' point, like there are lots of inputs now that we might be hard for a developer to obtain. I think even the way we do things at Red Hat, for example, if you are building stuff that needs rel content and you're just relying on Podman, well, guess what? If you're on a Fedora machine, you got to kind of bend over backwards to try and get some kind of entitlement for rel versus, spin up a VM that has rel and you subscribe it, and then you're able to do all those things. So even what we do day to day at Red Hat might mirror challenges that general public might have, where your build input are only available on that CI system, or easy to get on the CI system, whereas they're harder to get on your local dev machine.
I see Andrew and then Bruno. You guys want to proceed on cue?
Yeah, it was a really long conversation, and I really enjoyed engaging in that conversation. For me, I think that it draws a appropriate criticism or critique to the design of our builds. One of the things that I took away from it is that I'll back up a little bit. I think that one of the differences is definitely the difference of perspective on what reproducibility is. System reproducibility, or basically, do you trust a build system or do you not? Can you reproduce with a build system, or can you reproduce without a build system? But one of the things that I thought was valid to point out is that the prefetch task modifies the source. But I think in reality, what actually makes sense is for the prefetch task to not modify the source, for it to basically have a straight pass through for the source, and then add any kind of modifications that it needs on the source in its own trusted artifact somewhere. And then the build task would be modified to not assume that the source has been modified, but then to say, is cache2 pre-configured? Let's apply this script which modifies the source as we need. We can even copy it in our own temporary location if we need to, like we've started doing with the container file. We don't modify it in Git. We copy it to an external location and then apply the modifications. But then I think what becomes interesting is that it's possible for a developer to verify the build because it has access to those scripts, and it has access to that prefetch content plus the scripts that are run on the source. That ability to verify what the build system does is further strengthened by some of the conversations that we've had about reducing how can we reduce the length of the scripts in these Tecton tasks. One of the ways we can do it is by moving these scripts to be scripts in the container images themselves that we're running for our tasks. And so what if we think about a situation, we already have the build a task images. What if we take the entire, or maybe not the entire content, but a majority of the content that we have inline script in the Tecton task defined, move it to that build a task, and then in the Tecton task, all we do is we call out that script to perform the build. A developer can then, in their own environment, can use that same image, use that same input, and verify that the output is the same. They wouldn't use the builder they have locally necessarily, but it affords them the ability to verify the output, but also verifying the individual parts. Maybe they want to verify the builder image that's being used. Maybe they want to verify the scripts that are being used to modify the sources. So it's a way to not change it doesn't change the trust model. You're still trusting the build platform, but it increases the ability to understand the process and understand the data flow through the system.
Bruno, go for it.
Yeah, so I think I was going to say something in the lines that Andrew is saying. So we're thinking about reproducibility, but doing a hermetic build is usually not the same as doing like a standard build that has access to the internet, to the whole system. There are things that can change. I can give you a more extreme example that I have seen in a practical situation. Like there is some npm pull scripts that do some magic, get things from the internet. That build will never work hermetically unless you change actual, environment variables to teach that library not to fetch the thing it needs. So when we're talking about reproducibility, I think we have to consider that we need to configure whatever it's needed to do the hermetic build. And that is something that we are doing, the way we're doing, like changing the source of the container file to make it more practical for developers. We don't want people to have to think a lot, invest a lot of time to configure their repos in their builds in order for them to work hermetically. And I have proposed a simple situation. I completely understand folks that don't like the idea of having their sources changed. Anyone can, configure the build using Cache2. It's something more manual than what Andrew was proposing. But you can have a midstream, configure everything, and then we could have a flag, for example, in the build a task, in the prefetch task, that we would avoid all modifications. So, but then the burden of like configuring everything would be on the developer side, on the user side. But that is a quick solution, because all other proposals we have been thinking of, they are not easy. It might not be that obvious, but Cache2 has a lot of logic, because we try very hard not to execute any arbitrary code. Because the benefit we bring with hermetic builds is a more trustable SBOM, like something that we know that everything that's in the SBOM is in the image and nothing else was downloaded during the build. So that's the benefit. That's why we do all those, configurations and things like that. So that's a solution I can think of, because if we're trying to go for a way like, a transparent proxy, something like that, that is a huge investigation, and we would need to invest a lot of time to do it. And we don't even know if that is a proper solution. It can be, but we need to investigate.
Thanks, Bruno. Andra, I wanted to ask, can I get your opinion, or can I try to get you to proxy your team's opinion? Is your team more concerned about or more interested in reproducible builds as a security feature, as like the build is as it should be because it has reproducible properties? That's one way. When people say reproducible builds, that's what they mean, or what they're talking about. Or is it more about inner loop, local CI, and being able to efficiently work on your repo and produce a build that is as close to what is going to come out in the outer loop in the running a CI build?
So
go ahead.
it came up because of someone tried to do some inner looping and trying to debug a problem, but it was raised as a security concern. So it's kind of both, but it was raised as a security concern after finding out that it's hard to do the inner loop internally, like to develop the pipeline. So it was discovered because of it's hard to debug the tasks internally, so to reproduce for development purposes. But it was raised as a security concern, and the person who raised it was feeling that this is a security concern, that the sources are changed.
Okay, thank you. I wanted to take that comment back to what Andrew was saying about it was two things. One about taking what is currently our inline build a task script and turning it into a script that could be invoked more directly or more easily by the user to help support a local CI experience. That seems tractable and is something that could be done. Andrew, you were talking too about using having the modifications to the container file be part of a trusted artifact, and that, while it would maybe expose on the registry level more about what's happening in between, and would record what was the modified container file before going to build, making things transparent in a certain way, I think it would make the local CI inner loop part more difficult, because it wouldn't just be executing that build a task. You'd have to execute the prefetch task too, and then connect those things together, and suddenly it becomes more difficult than just running one bash script that does what our build a task does. Alternatively, you could be running that build a task to do new builds of your software locally, but you're only going to be getting exactly what the build system built on your last commit, not what's in like your dirty working tree, which I think is what you want out of an inner loop experience, is making little changes and running builds over and over again.
So the thought that I had about I use trusted artifacts, but I mean, it doesn't have to be a trusted artifact. It's just that the build or the prefetch step would not apply the changes to a Git repo. A prefetch step would require that the sources are unmodified, so that when you have the build task, the sources that are input to that build task are the same exact sources that have been cloned, if there are any changes that need to be made, that needs to be reported separately. Just like all the prefetch dependencies are not merged with the sources, those are kept in a separate directory tree. What we could potentially do is alongside that directory tree of all the dependencies, also create a script that is capable of modifying the source repo as we do in line with Cache2 today. So Cache2 would be modified so that it creates the script instead of modifying the source. That would then be able to support a inner loop iteration, because if you use trusted artifacts, for example, then that trusted artifact would have all your dependencies and it have the script that's needed to modify the source. And so from your local environment, you can leverage this build task or the script within this build image, passing as a parameter the source, whether it's locally or whether you produce your own trusted or your own OCI artifact with a source, and this other OCI artifact that has the prefetch content plus the source modifications, and then using that build a task image in the inner loop, you can say build this hermetically, and you'll be able to iterate on hermetic builds using or reusing a prefetch without having to re-trigger the generation of the prefetch and re-trigger the modification of the source, because you then and maybe it's not quite accurate, but in my thought, if you're not making any changes to those lock files, then the source modifications are going to be consistent. And so that enables you to reuse a common set of prefetch data and prefetch source modifications with some various number of Git references, as long as you're not modifying those lock files. So it enables inner loop iteration for testing hermetic builds.
Yeah. I worry it would expose the developer to so much cognitive load, having to know what parts of their repo they're changing to then know which parts of the build process they need to rerun. There's a certain part that they can rerun freely, but if they modify certain other parts.
But I think I won't disagree with you, but I think that this is also not going to be an everyday user that's interested in doing this. Verifying that they can reproduce a hermetic build, leveraging some prefetch content for package managers, which aren't meant to be built hermetically.
Mm-hmm. See Louis' hand?
Yeah, so I see this is maybe like a separate conversation whether to, but I see some parallels with the EC journey to being a CLI. Initially EC was basically a bunch of bash scripts, and a lot of it was embedded in a Tecton task, and it quickly became difficult to rerun, right? To retry things locally, and it also became very difficult to test. Now, I think with the build a test that we have now, what they're doing is it's very complex, and I think we're sort of like ignoring the fact or kidding ourselves that that is being done in the right way, because a lot of that code is not tested, and just basically because of the nature of how testing an embedded bash script in a Tecton task is it's hard, and if you want to get like full coverage, it's going to be expensive because you need like a whole cluster to be running, right? You can only go so far with things like shell spec and things like that. Yeah, Adam's comment. So I think we're probably way beyond the crossroads where we should take a step back and try to aggressively remove the pattern of just embedding a bunch of bash script in a tecton task. But I think we should go further than that and move away from bash altogether, because bash is not the right thing for this. It's quick and dirty, but it becomes really hard to manage over time. So if you could take a step back for a bit, how cool would it be if there was a CLI that you could call a command to prepare your source and another command to build the source, right? Kind of like prefetch and build. That would be something very simple that someone could run locally and get pretty damn close to what Konflux would do. And then you look at the Konflux, the tecton task used by Konflux, and it would just basically be a couple steps that just call that command. May not even need a script. You may just use the command to actually invoke things like that, and that becomes much easier for users to interact with it. And I'm looking at this from a different lens as well. I'm thinking of RHTAP, where we have to do these things in different CI systems. And if we had like a CLI like that was able to encompass all this functionality, we could easily run that on GitHub, and we could run that on Jenkins. We could run that anywhere, really. Because if it works locally, it will work on any other CI system as well. Just some food for thought.
Mm-hmm. I think that would be useful, Louis, for our development purposes, like you already mentioned, inside working on Builda, from the developer point of view of like a user of Konflux. To me, it would be nice to wrap something outside of the .tecton directory, CLI-wise, to do a local run. And the reason is that often I find myself making tweaks to what's in my .tecton directory, and I want to get feedback on whether or not that's going to work. And if I was using some, CLI tool that's embedded inside the Builda task, I wouldn't get the opportunity to start testing that stuff. Right now, I just have to rely on pushing to a pull request kind of over and over again, iterating on my outer loop until I find the right combination of parameters that does what I want for a change to my repo. I see Bruno.
Yeah, I mean, I like the ideas and the directions, but just some things about the current process. Like if you guys want to test cache2 locally, it's not too hard. It is already a CLI. It has like essentially two commands, one to prefetch everything that's needed, and the other one to change the source code. So they're separate steps, and you can do like then like in a sequence. I will post here a bash script I use to test builds locally, especially when I need to troubleshoot something. It might be a direction in case you guys want to see the whole process. It clones and prefetches, modifies the sources and builds. I think the only thing that the command that modifies the sources does not do is to change the Docker file, because the only thing we need in a Docker file is actually to use the environment variables that cache2 generates. It could be done. I don't know if it's something that the users would want. If you have any suggestions on how we can improve cache2's user experience, please let us know. I always thought we can have a lot of work to improve the user experience of cache2. But yeah, that's what we currently have. So yeah, feel free to take a look at the script and take a look at the documentation, because you can, at least the cache2 hermetic builds part, you can test it locally. It's not too hard. It can be better, but yeah.
I think one of the things to emphasize is that it's not so much about finding a way to try things out locally, is about reconciling the local process with what's happening in Konflux. And I think that's really important. So if we have like, run this set of scripts to try things out locally, and then the build is going to, run its own set of scripts, I think that's a risky approach.
And I clicked and I'm looking through your Dagger link. Do you want to?
Yeah.
You know?
Yeah, that's a complete side side thing. But yes, it might just be worth summarizing briefly. There is a project/product that is out there where basically you're turning CI into true code that you can run and test. Started by the Docker folks, and so it's very much still new, incubating, and I was experimenting with it a while back. It's right now, like, it needs to be full root on cluster. We lose all the secure supply chain stuff that we have with Tecton, so definitely a non-starter today. But the discussion of like, hey, let's be able to run our CI locally, that is a general problem that I think every single CI system faces.
Go for it.
Yeah, I think if we go, yes, running everything that the CI system is doing locally is kind of hard, but I don't want us to have paralysis because of that. Like, I think if we can take the individual steps that the CI is doing and be able to do that locally, I think that is a huge improvement and towards the right direction.
Any other comments on this? I think conversation's slowing down.
I know Vincent's here. I know he at one point you had linked to me a little while back. You had a concept pack runner where you could take your pack YAML and run it pseudo locally.
Yeah, well, I have been experimenting with the hooking up the TKN pack resolve command with the BuildKit Tecton project, but the BuildKit Tecton project is not up to date right now, so it wouldn't work. But like, there was a way for simple things to run locally, but yeah, and I have some code somewhere in my laptop maybe that turns some part of Tecton payloads into the Dagger graph, but it's not complete as well. But yeah, that's probably like, it's probably a slightly different topic though. But that's something that people, like even customers, usually sometimes they want to run some of their pipeline or some of their tasks locally more often than not, and we get, for a few times we get requests that, hey, how can we do this without having to spin up kind and stuff. So yeah.
Cool. Thanks for the discussion. I will point my team to the recording. I guess we didn't really come to any conclusion, but thanks for all the pointers.
Awesome. Thank you, Andre, for raising that. I'm going to stop the recording unless, let me double check the agenda. Is there anything else popped on while we were talking? No. Okay. I'm going to end it. Thank you, everybody, for coming today. Thank you for the discussion. And thanks again,
Thank
Andre.
you.
Cheers.